In a previous video, we looked at how to find the total number of zeros, the number of real zeros, and the number of imaginary zeros. In this video, I want to find the actual coordinates of those zeros. I'm going to show you two ways to do it. So I'm going to use this polynomial as my first example. Go ahead and pause the video, get that whole thing typed in if you need to. But I want to find the actual coordinates of those zeros right there. You'll see that, they turn out to be nice numbers in this case. They're not always nice. Sometimes they're crazy, irrational decimals. So let's just agree to round to 2 decimal places if we have weird values. So the first method I'm going to show you is actually using the 0 button on your calculator. So that's located under the trace menu. So select second calculate and then select 0. And what it's going to do is ask us 3 questions. It's going to say left bound, right bound, and guess, similar to what it did when it asked us to find the max and mins. So let's go ahead and find this one first, the one where it bounces, the one that represents a double solution. Well, right now, one of the difficulties is I can't even see where my cursor is. So use your coordinates down here. It's at 0, -14, so my cursor is somewhere down here. So pressing to the left a few times should make it pop up. There it is. All right, so I want to go to the left of that 0. Well, in this case, left is going to be somewhere over here. So I'm to the left of that 0, so press enter. Go to the right of it, so this time move to the side, somewhere over there, press enter. And then finally press guess, and it will pop up with our answer in just a moment. I believe, there it is. Now notice it didn't give me -1, but I need to round appropriately. So this is the calculator trying to tell you it's -1 because it can't quite get there. Sometimes they are actual decimals, so don't always round to a whole number. In this case, it is just -1. And notice I made a note that it represents a double solution because it bounces. Let's do the same thing over here and find this second 0. So I have to repeat that process. So second trace, select 0, and press enter. Once again, I need to go to the left and right. Now, this is where it gets a little confusing for some people because left and right really means above or below in this case. So let's trace over there, and I need to think about and watch where your cursor is so you don't lose it because these can jump really fast. So there's my cursor showing back up again. All right, so if that's my 0, to the left of it is actually going to mean somewhere below. Left doesn't always mean below, it just depends. So it's kind of confusing for people, so make sure you try it a couple times. So left is going to be below, so that's fine right there. Then they'll say right. Well, in this case, right would mean above the x-axis, above the zeros to the right of it. So press enter, and once again, just hit guess, or hit enter for guess. And that time it popped up exactly as x equals 2. So there's one method for finding the zeros. One quick thing to note, every now and then you may see an E pop up over here instead of 0. Like it may say 3E -12. Remember that E represents scientific notation. So if you see an E, basically it means 0 because it's a really, really small value. This case it didn't do it, but I think in class some people had that happening. So if you see an E, just know that that's a 0. Okay, that's method 1. Let's go ahead and take a look at a second way to find the zeros. I like it better, although it doesn't work for the bouncing solutions, but this other way will be quicker. So let's get a different problem to take a look at. All right, I've switched screens and switched problems on you and all that, so hopefully that wasn't too weird to just watch switch over. But here's my next polynomial. I've done a whole bunch of other work. We did this one in class where we found total zeros, max and mins. If you need help finding that stuff, then watch a different video. This video, again, I'm going to focus on just how to find these actual real zeros. So I've typed my polynomial in. Hopefully you have as well. I want to find all the real zeros. So you can use the trick I just showed you. Well, not really trick, the feature I just showed you. Here's another way you can find zeros. It doesn't work for those bouncing ones, but in this case, I noticed that none of my zeros are doubled, none of them are bounces. So the way to do it this way is as y2, I want you to type in y equals 0. And rather than using the 0 feature, we're going to look at the intersection feature. And I'm going to find the intersection of the line y equals 0, which is just the x-axis, and my graph. And I think this is a quicker way to do it, although it doesn't always work like those bouncing ones. It'll work a lot of the time. So let's hit graph, and you'll see a rough sketch, or you'll see the accurate graph of what I did a rough sketch of over here in a second. There it is. And so it dips way down, climbs back up. And here's my second line coming through, y equals 0, the x-axis. And so to find the zeros using this method, here's what I want to do. Hit second and trace. This time, select intersect. This is just another way to do it. You can, if you like the other method, that works absolutely just as well. Here's just another way to do it. So select intersection. We want to trace over so we're close to those intersection points. An even cooler trick, rather than tracing along the blue polynomial, if you press up, you can just trace left or right along that line. So that may be even easier to get to your zeros. This method is nice because you can just hit enter 3 times. You don't have to do left bound, right bound, guess. So I'm close to that 0. Just be close to the one you want to find. Hit enter 3 times. and it'll find your first intersection point. There's that e I was talking about. I knew it showed up somewhere. So that means -1 times 10 to the -12, which is 0.000000000000001. And don't count because I don't know if I put the right zeros in there. But it's basically saying that that answer is 0. So just if you see e, put down 0. Most of these are going to be really nasty decimals, so I've gone ahead and just rounded to 2 decimal places. So my first 0 is -1.14, comma 0. Repeat that process for all the zeros. I'm not going to do all of them right now because it's the same idea, but I'll show you one more. So second trace, select intersection. Remember, you can use the 0 method if you like it. This is just another way to find the zeros. Trace along, or if you press up, you can trace along the y2 curve. Let's go ahead and find the, let's find this one, I suppose. Doesn't really matter. So let's find that one. Press enter 3 times to find that 0, 1, 2, 3 for a guess. So that 0 is about 1.1 or 1.82, and I've got that one on my list as well. So I'm not going to find these last two. I trust that you guys figure out how this works. Maybe you want to try it using the other method, the left-bound, right-bound method. But there are 2 ways you can find the coordinates of the real zeros using your calculator.